Take a moment and think about how old you are. I'm guessing you've used years as the unit. If you know today's date and your birth date, you could determine it in days. Your birth certificate probably goes down to the minute, so you could do it in minutes. There are two problems with getting more precise than that. First, your birth certificate probably doesn't go to the second. And, the other kind of second, if you were born into a solar system that had 9 planets, you'd come up with an answer that's off by at least 4 seconds. Today on SQSR, we're going to answer, what is a leap second? Leap seconds are 1-second adjustments to UTC to keep UTC aligned with UT1, instead of running off at the speed of TAI. Yeah, I know. More questions than answers. But apparently some people don't like waiting to the end for the answer, so I gave it up front. But now I can explain it. When I was growing up, anytime someone talked about a time zone offset, they'd say something like 5 hours behind GMT, or GMT minus 5. And we learned GMT was based on solar noon in the Royal Observatory of the Greenwich part of London, England. But then at some point we started saying UTC instead of GMT. And I swear the reason I heard was GMT is ambiguous because they do daylight saving. Well, there are two things wrong with that. First, UTC replaced GMT for things like time zone offsets in about 1972. I might be going a bit gray in the beard, but I'm younger than that. I don't know why it took so long for vernacular speech to catch up. Second, GMT doesn't do daylight saving. Allow me to quote from the British Summertime Act 1972. The time for general purposes in Great Britain shall, during the period of summertime, be 1 hour in advance of Greenwich Mean Time. And the Summertime Act 2002 was worded pretty much the same. Apparently Britain hasn't bothered changing to UTC, or they use the new definition of GMT, which is UTC with an offset of 0 minutes. You've probably heard the phrase atomic clock at some point in your life, and while I'm not going to explain them today, it's just important to know that governments around the world have been using them since the 1950s. These clocks don't know what a day is, they count things in seconds. Or for cesium-based clocks, they count atomic vibrations and divide that by 9,172,631,770 to say how many seconds have passed. So, if a cesium clock is turned on at exactly noon on July 1st, and it has counted enough vibrations to total 1 million seconds, then we know that 11 days, 13 hours, 46 minutes, and 40 seconds have passed. Therefore, it's July 13th, and the clock should say 1:46 a.m. and 40 seconds. So, take a bunch of atomic clocks from all around the world, get them to report how many seconds have elapsed since some known point in time, called an epoch, make sure that they have all accounted for altitude and gravity effects, average them all together, and you've now got the timescale called TAI. In English, we call it International Atomic Time. The initialism comes from French, temps atomique international. The original definition of Greenwich Mean Time didn't measure seconds. I'm going to gloss over a lot and say that it tracks the percentage of a day that has passed since solar midnight and assigns a time based on that. So if the sun is at exactly 72 degrees after solar midnight, that's 20% of a day's 24 hours, we get 4:48 a.m. And of course, that's as measured from the Royal Observatory in Greenwich. So you could say that GMT counts days from solar midnight to solar midnight and can interpolate between them. Well, the Earth is a sphere, and that means it takes light slightly longer to get to Greenwich at 51.477 degrees north latitude than it does to get to the equator. So, correct the GMT system for latitude, and you basically get the timescale called UT1, or Universal Time 1. There's also a UT0, which is just old GMT, and UT2, which is UT1 but corrected for seasonal variation. But UT1's the important one. Okay, so now we have a clock system that measures seconds very precisely, and a clock system that measures days. We can translate between them because there are 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute, and we just need to apply the scale correction factor of 86,400, Right? 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 Of course not. Otherwise, there'd be nothing to talk about here. On the long scale, days are getting longer and longer. April 12th, 1972 had the audacity to last the normal 86,400 seconds and then an extra 4.355 milliseconds, making it the longest day in recorded history. So, yes, the amount of error is small, but just like with the Julian calendar, these small errors add up. If every day was as long as April 12th, 1972, then after 230 solar days, UT1 would declare that 19,872,000 seconds had elapsed, and TAI would be just slightly past 19,872,001 seconds. On average, it's about a millisecond and a half gain per century, which, were it purely linear, would mean that every day was 41 nanoseconds longer than the previous day. And now we can finally get to UTC. In English, we normally just call it UTC, though we have been known to abbreviate it as CUT for Coordinated Universal Time. Bizarrely, UTC isn't the French abbreviation either. In French, it's Temps Universel Coordonné, or TUC. The Francophones and Anglophones agreed to settle on UTC since it didn't match anyone's language order. So UT1 is the English order, TAI is the French order, and UTC is agree to disagree. Nice. The idea of UTC is that it should change days at the same time as UT1, but it should agree with TAI on how long a second is. But we've already seen that that's impossible. So, what's been done since 1972 is that whenever UTC is more than a half second ahead of UT1, a leap second gets thrown in at the next half year, taking UTC from being half second ahead to a half second behind. When a leap second happens, then either June 30th or December 31st will follow 23:59:59 with a strange time of 23:59:60, and then carry on over to the next day at 000. And then UTC is behind UT1, slowly catches up, overtakes, races ahead, and then a new leap second is thrown in to fix it again. The International Earth Rotation and Reference System Service, which is headquartered in Frankfurt, Deutschland, are the ones who are responsible for announcing that a leap second will occur. Had I made this video in 2022, we'd stop there. But in 2023, the International Telecommunications Union agreed they will come up with a new maximum deviation value of UT1 and UTC by 2035, which might end up eliminating future leap seconds. Especially because that whole on average days are getting longer is running really hard into that word average. You see, we have microsecond data on the length of every day since January 1st, 1962. And as of June 19th, 2026, there have actually been 2,065 days shorter than 86,400 seconds. Cumulatively, they only add up to 863 milliseconds, short of the 2,065 full days, but there were no short days at all in the first 24 years of this dataset. The first short day ever was August 2nd, 1986. Clearly, since there are now so many fast days, they have been happening a lot more often. In fact, 57% of the days, January 1st, 2020 through December 31st, 2025, were too fast. There was even a discussion of doing a negative leap second at one point, which is what prompted just allowing the clocks to be further apart than a second. Why are, or maybe were, days getting longer? Well, the primary answer is tidal breaking caused by the moon. Why are they getting shorter? I don't know. And I suspect the answer isn't simple. If you want to know, maybe ask Neil deGrasse Tyson. While you're at it, throw in a jab about Pluto. I hear he loves that. Most humans aren't really bothered by leap seconds. To us, time is mainly just whatever the computers say it is. But computers are often used to calculate the amount of time between two events, and leap seconds gum up the works, especially for computing the time an event will happen in the future. And that brings us back to the introduction. Since June 30th, 1972, there have been 27 leap seconds. I've numbered them as 1 for the most recent, so you can just find the one that's closest to your birthday to know how many extra seconds to add to your age. And since I brought it up in the intro, the IAU declared Pluto not a planet on August 26, 2006. Okay, so there you have it. Now that you know what UT1 and TAI are, and how UTC relates to them, perhaps you'll agree. Leap seconds are 1-second adjustments to UTC that keep UTC aligned with UT1 instead of running off at the speed of TAI. See you next time for another simple question and simple response.